be able to get it from the YouTube thing.
Just from our channel.
No, the YouTube like management window.
Here.
Yeah, the little right arrow pointing right, top right side of the screen.
Oh, I think we said that
Yeah.
last time, didn't we? Okay, I'm going to share this to a few places and see what happens. Don't know if he'll care. I mean, he's the only one that posts. Maybe I shouldn't. Bad network quality. Awesome.
What channel is this?
This is Grub's one. So like Grub was promoting our streams on it, so I was like, oh, okay, fine, I'll just start doing it then.
Nice.
Oh, I could have called it like getting into the pink or something.
We just so I don't know. I just part of me wants to keep it vaguely family friendly.
Fair. I don't know. I could share it in Pinky's Discord as well, but I don't know if I'm allowed to because no one else has before except him. So.
Oh, are you on Pinky's Discord as well?
Yeah, he's got his own. So.
How did you get access?
I asked him about. So the download link for Pinky's Palace 4 was like downloading at 10k a second, like 10 kilobytes a second. So I sent him a message on VulnHub, and he said to come here to download it because it was way faster. This was ages ago now. Doesn't matter. So that's it really. None of the other ones are actually really hacking related ones. Whoops. Let's kill that in case it does anything. I don't have... Oh yeah, I do have chat and stuff open just in case anyone's already here. Where else do we share this stuff? Slack. Yeah, plus I guess we share it to work Slack, so probably not a good idea to name it anything too bad.
Oh yeah, I've hopping on the old channel. I can confirm it's all working. People get to listen to us farting around.
That was kind of the point of this stuff, is us fighting around.
So anyone who is tuned in, which I think says 2 people, that might just be you and me. We're just we normally start properly at 8. We've started just to start the stream early, just where we might banter a bit, maybe look at some news, discuss what's going on. All depends, I suppose.
All the stream prep stuff.
The sound of like jangly electric guitar strings in the background.
Not plugged in electric guitar.
What was that?
An electric guitar
it's plugged in.
Oh, it's just...
Oh, it's plugged in, just no one else can hear it.
Oh, okay. So we get to hear the acoustic version, and you're hearing the nice, pretty electric version. Um, okay.
I'm with it now.
So now we've got 20 minutes to kill because I think we're just about ready.
I will put this. I'll put this down. I'll put it first. Good target. Yeah. No, I was just restringing it while I was waiting for you.
All good.
Right. Move microphone into position. Man, how weird is the world right now?
It's a bit weird, yeah.
The number of memes on some of the like sysadmin subreddits are pretty funny. Oh, just like, and it's the case that where I'm located currently, they've been doing all these like mass mass remote desktop tests. So checking that VPNs work and stuff like that. And I'm guessing a lot of companies are running into the same problem. It'll be interesting to see how Microsoft handle things, given a lot more companies are going to be using a lot more Microsoft.
Yeah.
Although it probably won't hit. Teams probably will get hit, but the rest of Office 365 is probably going to be fine, considering that the way you use it anyways in the cloud, even when things are normal. So,
Well, there was an article
unless
that
there's
they were
lots more places
blocking,
migrating,
they were reducing a lot of their telemetry. So, like your present status and the typing, when someone types, those typing indicators and things like that.
Yeah, with Teams, I could see that.
Yeah, just to help reduce a bit of the bandwidth to cover what they expect the increase to be. But yeah, it'd be interesting to see.
It's probably the same with Slack and stuff as well.
Yeah, that wouldn't surprise me.
It's just weird times. I'm assuming most of the people working this are going to be based in Australia, but if you're not, we're in Australia. As you can tell from our accents, we're not from the UK or from New Zealand or from South Africa. They're all very different accents.
You're looking at the screen, I just realised.
I am. It's my sister just sent me a Sesame Street meme. It's all the Sesame Street Muppets are wearing like face masks. It's like, today is brought to you by the letter C and the number 19. Yep. But yeah, it's where I am has like they're half the staff from a bunch of teams are now like work from home. I think they said early next week that we might hear more news about a proper actual lockdown.
Oh, okay. Yep.
Attacks are on the rise. So, at least I kind of go, well, it's funny because my job is kind of justified by bad people doing bad things.
Yeah.
And people are doing more bad, which is like, but there are people who aren't in the same situation. A friend of mine's in an industry that's like kind of at risk throughout this because folks need people to be willing to be together in groups and or be allowed to be. So
yeah, I know that.
Just having a bit of a look at Amazon's looking to hire 100,000 warehouse and delivery workers.
Wow, okay.
I know retail with distribution centers, so retail that does a lot of online stuff. Yeah, I can see your OBS screen, which is the wrong screen.
No, it's the right screen.
Oh, okay. But yeah, a lot of retail's trying to ramp up in Australia, and a lot of like delivery and logistics is as well. Geez, what else here? Low cost Arduino based ventilator. Yeah, that's a problem. They don't have enough of those in Australia. And they said they were like 2,000 short. By the way, don't take anything we say, especially in this bit, as anything other than perfectly casual observations by people who don't know anything about anything.
Pretty much, yeah.
This article's all in Italian, but the headline is 50 to 75% of di casi a voi sono asymptomatici una formidable fonte di contagio, which apparently is 50 to 70% of COVID-19 cases are asymptomatic. I don't know any Italian. I was just reading it out.
That's fine.
Um, Interesting. I don't know if that's just a little bit of research or confirmed, but that's kind of a scary thought. If it was like 75% or even 50% at the conservative end, and you've had 80,000 people in China, that means 160,000 people have really had it. That's nuts.
So, because I've been doing a lot of stuff in Python recently,
Yeah.
and I've also been flicking in and out of Visual Studio Code and PyCharm, and VS Code's been prompting me heaps to download their Python extension because it's noticed that I've been looking at Python files. And I just, like, there was an article posted today of a RCE vulnerability in the Python extension for Visual Studio Code.
Oh,
So lucky I haven't been installing that.
lucky I always use PyCharm for Python stuff.
Yeah, exactly.
The groceries that no one wants to panic buy. Hacker News today is mostly just coronavirus related. Here we go. Spaghetti made from chickpeas, chocolate hummus.
Oh man.
It's Dasani water, which is a UK thing, I think. Obscure canned vegetables. Actually, let's see what else is going on. This last week I have not been paying attention to like the more infosec news.
No, not really either.
Purely because there's far more interesting news going on at the moment. HTTP desync attacks, Visual Studio Code extension RC vulnerability. Yeah. Turned blind RC into good RC via DNS exfiltration. We've done that in the stream, I think. One of the HTTP boxes had DNS.
It was a DNS, yeah. I can't remember which one now. My yearly VIP was up for renewal and I didn't do it, so I don't have Hack the Box VIP anymore.
Mine did.
I haven't touched it in like 4 months.
I didn't know until I'm like, what's this $100 bill? Oh, Hack the Box renewed. I guess I've got it for another year.
I guess I got it for another year. I mean, I could do it if we were going to start using it again. I would, but
yeah.
I haven't. So
another RC and Horde webmail. It's to do with repo cloning with the Python extension. Oh, I think yeah. Okay, so it's remote code execution, but through the fact that it's not the actual extension itself, it's the way VS Code handles it. So actually, no, it is extension. So when you load a folder with the Python extension, it'll go to the N folder in that folder dynamically.
yeah,
And I think he's basically saying from there, you can. There's a settings.json as well that you can define where it is, which basically means then you can start to use any of the like repo overlay attacks that we've got. So if someone was trying to use like some sort of other Python, you could override that when they go into your repo if they used the, I suppose, local Python stuff in VS Code. Which actually on my work PC, I should see if there's a patch to this.
They said the patch will be out mid-April.
Oh no, I don't have the Python thing installed. Sorry, I'd used the terminal, but then I just spin up the virtual env myself. I don't use the Python add-on. I don't think I've ever used a Python add-on for this. I've used like the Python syntax stuff, but not the yeah.
The actual IDE type stuff.
No, I just use the terminal and then I you spin up the local virtual env myself.
Yeah, cool. Should be fine
I mean,
then.
it's really just never trust someone else's virtual env. I mean, really, I suppose that extends to never trust someone else's requirements file, but at the very least, you're going and getting stuff from the original source. What's the time? 7:49. Let's move on.
If you can hear stuff in the background, I have people over that don't know how to be quiet. So just ignore that. It's fine.
Relatives.
Yeah.
What else is going on? I don't know. There's not too much interesting in the infosec world at the moment.
I was just
I think
thinking
that's.
that, like, there's nothing too.
I mean, I'm sure there is. I'm sure there's like some big thing that's just going nowhere. Oh, making an aimbot for Doom.
I saw that article for like a different reverse engineering sort of thing. There was also last week another SMB vulnerability.
Oh yeah, I saw that. Microsoft's got a patch for that coming out soon.
Yeah, I think they have, or it's pretty close to being
Yeah.
patched.
Of course, what's funny is a lot of big companies have change freezes at the moment, so that's going to slow down patching. That's the thing. Like some of these other, from an infosec lens on some of the stuff going on. So you've got phishing related to coronavirus going around. There was that. Was it the Johns Hopkins coronavirus map got hacked and was serving up malware?
Yeah.
Um, I mean, these are like watering hole attacks, I suppose you could call them. Um, if other big vulnerabilities come out, the speed of response is going to be that much slower. I certainly know where I am at the moment is focusing a lot on just operational stability. So patches, even for urgent stuff, are going to go through that much slower.
Yeah, that's
Um,
true.
what else? People working from home. I saw an interesting. It was in the context of a meme, but effectively it's like people who work at companies that print out a lot of stuff. They go home, can't connect their work printer, so their work computer to their home printer, so they just start emailing stuff to themselves to print it out. Like there's I think we're going to be surprised with the issues we see over the next 6 months.
Yeah, that's true. For how long it's gonna last and everything else. Oh, my monitor keeps going black. That's dumb.
It's Jake's having a minor technical issue with his.
Oh, my internet's crap at the moment. My monitor keeps dying.
What is it, like 20 down and 30 up? Your upload's
Yeah.
faster than your download.
Yeah, my upload's
Was
faster than my download. It should be nearly 5 times faster
it was like
than it is.
1.8 down before.
Yeah, that was.
Mine's fine. We haven't had issues like that here in Melbourne, but up in Queensland, I mean,
Yeah, that's it.
with Bogans,
All the bogans streaming
busy running the internet.
whatever they're streaming.
Yeah, man. If Netflix a publicly traded company? Now would be the time to invest in like Netflix or far. It is publicly traded. Oh, and it's gone down. I was like,
Wow.
oh, Netflix will surely be going up. Oh, well, it was. At midday, it was up a high. Let's see if I can get like a week, like a 5-day average. Or a month. Nope. You look at a month-long average, Netflix has been... Man. If you're going Google Netflix shares, it had a spike through February, like rise up as the coronavirus kind of fear started to kick in, and then from 4th of March it started to go back down.
Wow.
Oh, I have a feeling maybe it's because it was overbought, and then people wanted to ditch it because maybe they had risky positions they wanted to get rid of. Either way, like online entertainment, gaming, pharmaceuticals, online, predominantly online retail, probably all good things to get into. I wonder if at the end of this we'll see far more online retail as well, like businesses that were traditional just disappear because they can't, no one's coming to their shop.
Yeah, probably. It wouldn't surprise me if that happens to at least a couple of businesses.
I'll have a read of that later. What's the time now? 5 more minutes. Man, just dead air.
Just dead air.
Oh, SSRF on Slack via turn protocol. What else we got? I don't know. It's not much to look at.
We could just start early as well. I don't know if this is going to go for an hour or longer. It took me a lot longer than an hour to figure it all out. So it'll probably take me longer than an hour to explain it all.
In that case, maybe let's get started.
Not the 5 minutes.
4 minutes early.
It's going to make any difference. But yeah, so Pinky's Palace 3, episode 4. We are... When we left off last time, I think we were PinkSec management, looking at the PSM CCLI.
Yeah, trying to figure out that printf overflow business.
Yeah, the format string stuff. So I spent a couple of hours on Monday night, I think, Sunday or Monday night, working through all of this, and I finally think I understood it. Pretty much we're still following that same article that we started with last time. I don't have a link to it, of course. Hang on, let me just bring something up that has it. It was like coding something. Come on. We get to enjoy
Coding Arena or something like that.
Yeah, Coding Arena. The joys of my slow internet. Because yeah, the upload's fine. It's just the download, which is a pain in the ass. I can't believe I didn't put a link in our write-up. Oh, dude, that's so slow.
Wow. Welcome to Australia.
Damn it. Might have been exploit, not vulnerability. Yeah, no, not that one. This one. Code Arcania. Okay, Arcana.
Oh, there's a link in our teams. I could have just said that.
Yeah, it doesn't matter. We found it. So we sort of talked about this last week, or the week before, whenever we actually last streamed Pinky's Palace. And we knew the theory of what we had to do, but we didn't actually know how to do it. So pretty much what we've got is hang on, let me just catch up on the write-up. So we figured out that there's a printf function being called in PSM CCLI, and that it is vulnerable to a format string exploit, because we ran sort of this test case of all of these %Ps, and it did exactly what we would expect and print a bunch of memory addresses. From there, I'm not sure how much else we explained, so I'm just going to start from the start.
Yep, all good.
So we've got our SSH access on the box as PingSec management, and we're looking at getting to Pinky, because when we looked at the binary, it's in user local bin psm ccli. It's running as Pinky. Well, it's owned by Pinky with the sticky bit. So from here, I'm just going to move to temp so that we can upload or play around and create files and stuff in somewhere that is safe and temporary, and make a start. So first of all, to prove the concept, we run exactly what's in this article, which is just a bunch of P's, and the P's just lists out the next 10 pointer addresses. So the P just lists out a pointer address from the stack. And we can see that our args are all pointer addresses, so we've got a printf vulnerability. Next, we need to find if we can control any of these addresses. And the way we do that is by, it's similar to how we would do it in a buffer overflow. But in this case, we just sort of print out our 4 A's and then a bunch of stack pointers to see if we can see our 4 A's anywhere on the stack. In this case, for us, 200 is enough. This is going to test us to see how easy it is to find, but there's a bunch of 41s. And there's the rest of our 41s. So we can see that our stack isn't quite aligned, in the sense that our A's aren't controlling a whole single memory address. It's kind of split across 2.
Yeah, so this only works if you have everything neatly aligned. You can't jump to a memory location that's like
Half a
0.5.
Yeah.
You can't go to take me to memory location 1000.5. It doesn't really work like that. So you've got to kind of align them to the 8-byte kind of size, which is easy enough. It's just you've got to, I think you're about to probably go into it in a bit, but you got to go at it smart to make sure it is easier to do. Than otherwise, every time you change something, all the like alignments shift and you're back to square one. And
Exactly. So if we change this to add some B's, and then I think I added 2, I want to say it's 2 C's. When we look now, we can see that our 41s are all aligned, our 42s are all aligned, and then our C's we don't actually care about because they're sort of just there to help pad out the memory addresses. Now a part of the tedious bit begins, because we know that we control these memory addresses, but these memory addresses aren't directly at the start or directly at the end, and we need to know where positionally on the stack where these addresses are compared to where we are.
Yeah.
And we know that,
and that's the challenge with the Code Arcana one, where the first example uses a mem copy and a buffer to or a string copy into a buffer to specifically limit you having to deal with the stack constantly changing.
Yeah, exactly.
Which once when we were going through this and I was like, that's what that's doing. That's why that was so much easier than the real thing.
Yeah.
Kind of made more sense.
And we know that ASLR and things like that are disabled because, well, we used other tools to figure it out, like in GDB and things like that. But also, our stack doesn't change. I mean, it looks like it changed because I resized the window. But none of the memory addresses or anything change, and our locations are the same every time we keep running this.
Yeah.
So now, from here, we need to figure out how many memory addresses deep our 41 and 42 is, and I was super smart and counted manually and figured out that it's number 135 and 136. is our A's and B's. So what that means now for us is that we can call something like this, which is just going to display the 135th and the 136th memory address. So if we run that, I think, oh no, have they changed? 434343. Oh man, don't tell me it doesn't stay the same. That's gonna be fun. Let's try 6 and 7. Two C's. Okay, let's try this one. Hang on. Oh, what have I done differently? So it's not that I've done anything differently. It's that something's changed on the box. Maybe I didn't clean up my path. So we end up using our path later, and I'm pretty sure that's the problem. So our offsets are actually different.
So I think we mentioned this 2 weeks ago, running through this, but when an application starts and it's got its stack, part of the stuff in the stack are like the environment variables and the like input arguments and stuff like that to the executable. And so if your path changes between runs of things, then the offsets will change.
Yeah.
Yeah. Every time your argument length changes, the offsets change it. There was another approach to this which involved deliberately setting up it was like a script that set up a clean path for the executable to run in so that you could avoid all of that.
It's not there though. So my custom environment variable isn't in there. Okay. This is classic streamer curse.
Yeah, but Ninja doesn't have to worry about his offsets changing when he's playing Fortnite.
This is true. So I think it's actually 30. What did I try just then? Hey, BBB CC 136 and 137. They don't look aligned either, which is always fun.
Oh, getting there.
It's getting there, but also so 137 and 138. Okay, that's what we want to see. So
that's what we were talking about with some of the...
This is the tediousness of going through it, and I did this like hundreds of times trying to get these to line up.
It's almost like a chicken and the egg problem where you go, I've got to move these to hit that, but then by moving them, you've moved the target, and you're like, oh man, and you kind of have to try and think 2 steps ahead. And it's not easy.
Yep. So this is going to break almost all of my copy pastes now. But that still should be... I should be able to take, in theory, these 4 off now and just drop that down to 36 and 37 again. No, fine. Don't work the way that I thought you worked. All right, cool. No worries. We're just going to have to figure this all out again on the fly because there's some maths involved later, which was a pain in the ass to figure out as well. All good. So, because we want to write... So, at the moment, we're just writing A's and B's and C's. But eventually, we're going to want to write bytes. So, I changed just this string into a Python, which we've already used up here. And I have to update all of these to 37, 38, and add 2 of those. Cool. And we get basically the exact same result. But now we can write bytes here instead, and we'd not have to worry about escaping characters or doing anything weird or fancy. Cool. So now that we know that we can control memory addresses and we've got direct access to those memory addresses, we need to find a place in the application to redirect execution flow to run our shellcode when we get there. So to do that, we use object dump, which is on here, and this one I can copy paste. So object dump shows us in our arg show that straight after the printf that we're calling, it calls this putchar plt. And if we look at what that does up here, putchar plt calls a jump to this, the address at the memory at this pointer. Yeah, there's a pointer.
Yeah.
Let me try and word this in a way that makes sense. It makes sense in my head and I just can't. So putchar is pointed to by this address. I think that makes sense. Basically, we're going to jump to this address to call putchar. So what we want to do is replace this address with the memory that we control, and instead of jumping to here, we're going to jump to wherever our shellcode is. That makes more sense. So when I was looking up ways to do this, we tried the NOP sled and I couldn't get the NOP sled to work. And then I was looking at a few different articles on how to do NOP sleds and buffer overflows and things like that. And there was this article on OWASP about it was talking about doing NOP sled stuff in buffer overflows, but then it talked about using environment variables. And at the bottom of the article, it says that you can place your shellcode in an environment variable and execute it from there. So what it sort of goes into detail in the article about is that when you run an app, the environment variables are also on the stack. So if you can control or set an environment variable, it will have a memory address. And if you can jump to that memory address, you can execute shellcode.
Yep. So the way we were looking at doing this originally was playing around with the global object table to try and get ourselves to a call to system.
Exactly. And that's what this article runs through.
Yeah. So that one runs through how do you get something to system. Whereas, so that's almost, you're not really doing it for the same type of code execution. You're looking for an existing call in the object table, overriding an address on the stack. So you jump to a different location and give it a different argument. Whereas here, we're just writing our own shellcode and outright hopping to it and running it.
Yeah, exactly. Yeah. So in this article, it talks about the global offset table and just sending an argument to a system call, and their argument is just sh and then a comment so that it doesn't run anything else. And we can't do any of that stuff because our app doesn't have a direct call to system. We've got jumps to memory addresses, and that's why if we can just dump something in the stack somewhere, which the environment variables let us do, once we can figure out what that location is, we can just control this jump so that we jump there and execute our shellcode instead. So on GitHub, there is this get env address source code, and it's an app that basically will tell you what the memory address of an environment variable will be for an application when it's executed. So it's probably easier if I just show you how it works. So we're gonna go make the get env and go there, just so that we keep clean, because we're going to be writing a bunch of different apps in here. Get env.c, because I don't actually care if it's called the same thing. Now that balked. What's set paste in Vim again?
Oh no.
There's a button to set paste, and I can't remember what it is.
Oh, that's right. Yes.
Control R. What? That ain't right.
Oh, GVim. It only works in GVim.
Okay. Oh, well, it doesn't matter.
Oh, no. Go back.
It's not Python, so it doesn't matter.
You type set space paste and then do it,
really?
and prevent it from trying to reformat it. And then you got to go set no paste afterwards.
Oh, I need to learn
it says
my
that.
hotkeys.
It says that just in the Stack Overflow there. I'm not.
Oh, does it?
Yeah. So, yeah. Down a bit. Yeah.
Oh,
anyway, that'll do it. That's the Vim lesson of the day.
There we go, Vim lesson of the day. Except for some reason that didn't copy. So let's add that back. Oops, it's not include. It's not it's not nano. I did Control X. Then we just got to compile it. Except it's -o, not -p. And user bin, user local bin, PSM CCLI. Oh, I think we actually have to tell it the name of the environment variable that we want as well. So to do that, we're going to create an environment variable with our shellcode in it. So I took just a random bin sh from Shellstorm. I don't think it actually matters which one you use, but I used this one. It's a 25 byte, quite small one. Environment variables can be super long, so we don't necessarily care
Path's
if it's
a great
a short
example,
or a long one. Yeah.
But Path's a long one, so.
So basically all we want to do is export this into our own environment variable, and that's what this will do. The echo en basically stops it from adding a new line at the end of it, and also interpreting the backslashes as escape characters and things like that. So now we should be able to run our getenv. I think the first argument is the name of our environment variable, which is those guys, and then the binary that we are going to run, that we need to know the address for. User local bin, PSM CCLI. Okay, and that tells us that when this app runs, those guys will be at this memory address. So let's just open some notes and take some notes. Come on, you can open notes. Hello, notes.
Notes? Come on, notes.
Maybe not. Come on, let's try cherry tree. There we go. This opens at least. Oh, just let me work. Don't care. Don't care. There we go. So that's where our environment variable is going to be. So now we know that we can control the memory addresses at 137 and 138 from back up here. We know that our environment variable will be at that memory address, and we know that at this 0804AC, A1C from up here, which I should have put in notes as well. Where are we? Puts this one. And we know that that is the address that we want to overwrite, where put char is. Now all we have to do is figure out how to write this value onto the stack where this one is. And to do that, we have to do a bunch of maths, which this one sort of goes into back up here when it talks about its Python hex calculator stuff. If I can find where it is. Here. So it sort of does a bit of a calculation, which we couldn't quite get to work when we tried to do it either. But I read up a different article on how this stuff actually works. And so what we need to do is split our memory address in half and then calculate. We have to convert the hex into its decimal equivalent.
Yep.
And then write that to the stack. So the HN, if we look back over here, sorry, I'm jumping around a lot because this was very confusing for me and I've only looked at it once.
I think I had a glimpse in my head of understanding this and then it disappeared.
So, okay, so this here, we still want to follow this format for our payload, right? We've got our address plus 2, our number, and then our offset, and then another number, and then another offset. So this number here is going to be the decimal representation of our hex, because we need to, the HN argument, which is what we use here, is the right short word. I think it's called short word. Yeah. Short word right, which is basically a 4-byte word that it will write to the stack. And so it's got a maximum value of 0FFFF. So we need to figure out how many decimal characters we need to write to make HN write our characters, which are the BFFFF74.
And this is effectively where, this is effectively where you need to write the upper and lower parts of that value, because the N takes the number of characters that have been written and writes it to a place in memory.
Yes.
You do that twice.
Well, because it's only 4 bytes long and we need to write 8 bytes. So we need to split that in half and write it twice.
And doing that this way effectively then writes so normally you'd give it a pointer for it to write its value to. If you don't, it'll just write it to wherever on the stack. And so effectively what we want it to write is the value of the memory address we want it to hop to, right? But we have to do it because we're doing it in 2 halves and we've got to fub some stuff.
Yes.
It gets a bit weird.
So basically what we want is we're going to have, this is probably way too small. Here we go. That might be better. So we've got our
good.
upper and our lower. And this is what we're talking about. We're just splitting it in half into 2 4-byte chunks that we can actually write using the HN small word write. So our upper if we look at what this is in decimal, we've got 49154. So what that means is, in order to write those 4 characters with HN, we need to write that many. We need to have an input length of that many characters.
So what happens is it'll go, that many characters have been written, the hex value of that's that. So we kind of have to do this for it to all end up back in the original format in memory.
Yes.
Yes.
And so then our FF74 comes out to be that. But we have already written a bunch of characters as padding. And this is where the maths is going to be different, because I only had 2 C's, but now we've got 4 C's, which isn't much difference. So we've got our 8 characters for our A's and B's, and then another 4 characters for our C's. So what we actually need to do for our lower, so because it's a little endian, we flip them around. So we're doing our lower first. We need to do, I should make that an equals probably. That would make more sense since we're doing maths. Okay.
Yes.
So this is what we need to write these bytes, but we've already written 12 bytes, so we can take 12 off that, which is 65384. Yay, maths. I can do that one without a calculator. So now, if we do something like this, see, I will need to change this because it's all changed. We need to write 4 C's, and we need to change this to 65534 because we added 2 more bytes. Oh, right, actually, we need to stick that on the end of our... we need to stick that on the end of our PSM CCLI.
Yes.
I think that actually also needs to go inside that Python. Oh, I forgot what I copy-pasted this from. Let's just go like this instead. Standard, yeah, so I think it's that bit there. Oops, nope.
Ba-boom.
Where's the paste error? Find another bracket. Nope. Balls.
Oh, all of that stuff's on the wrong side of the. Oh no, all good.
Right, that closes that bracket. That closes that bracket.
Wait, no. Why are you closing the bracket at the CC?
37 and 38.
Yeah, you're closing it halfway through the right. So you need 2 brackets at the end then.
Yeah, okay.
And
I'm gonna need
that quote needs to go.
That quote and that quote needs to be here.
Yeah. And then a bracket
then
to
a bracket
close
there.
yeah.
Okay, cool.
There we go.
Alrighty. So that doesn't look like much, but it's actually helpful. Now, when I was doing this the first time, I was just doing it with... Oh, I've screwed that up as well. So I was just doing it with HN and just X without this 0. But the 0 adds the padding, which means that all of our previous bytes will be the same length. Like all of the previous bytes that it's printed on the stack, especially when we're counting bytes, it'll pad them all out. If I go back up here, we might be able to see it. So things like our zeros, anything that started with a 0 basically gets padded out. So like these ones will get padded and stuff like that, so that it's a consistent length, which helps us with our maths calculation-y stuff. Okay, I hope you're not lost, because I feel like everyone should be lost.
I'm keeping track. I'm hanging in there, man. I'm hanging in there.
Okay, so basically what we just did was we calculated the lower word because we came to this number, but we haven't written any extra bytes for the upper word yet. And that's why we're printing out a bunch of stuff, but it's not what we're hoping to see yet. Now, to calculate the upper byte, we need to do something called a integer overflow, because our BFFFF, because this number is smaller than that number, we can't just say this minus this, because we'll end up with a negative number. And this is where we were sort of running into our issues. Remember when we were following this and we were getting negatives at this Python stuff?
Yeah.
And we were like, oh, maybe we just get rid of the negative and it'll be fine. So theirs works out perfectly fine because their upper is already smaller. Larger, sorry. So now what we need to do is basically add a full FFFF to this one, so that when we, how do I explain
subtract
this? When we subtract,
stay,
we will stay within the realms of something that it can render out, or that it can hex out into the right value. So basically we make this by just adding a 1 at the front. And I don't want to open a new one. I want to go back to our calculator. And so now if we take this minus this, because we've already written this many characters to the stack, we get CO8B or that.
Yeah.
So that's this upper minus lower. Oops, paste. Cool. So now that we know this value, this is what we want to write in our second section here before to override our 138 memory address. So saying all that, this should just copy paste and work.
Do you have to fix offsets?
I will have to fix the offsets to 38 and 37. And I'll need to change that number to 4 and add 2 C's. And we get segfault. That's not supposed to happen.
Progression?
It is progression. So basically what we're doing now is we're writing too much to the stack, or it's trying to go to a memory address that it doesn't
actually have access to. Yeah.
So now we got to sit here and calculate where I went wrong.
Think, Jacobado, think.
So 1BFFFFF, if we just stick this in here, is that, which is fine, because then we take 11,4,687 minus that. Is there a calculator in this? That looks like that is not a calculator. Python is our calculator. So this minus this is 49291. Yeah, which is right. So then we need to write 49,291 bytes into the small int for that. And we've already said that we're doing 65384 here. Oh no, never mind. I'm done. I know what I did. So
that's good.
We need to go back to the start again. So because we did an export and added to the environment variable, our stacks changed. I ran into this the other night. Yep. So we need to go all the way back to...
Which this is what makes this harder than like some of the other examples, because the other examples you were just trying to override the like offsets table, and so you could do a lot of pre-prep and use a fairly generic pre-prepared like template attack string almost, and then just sub out the bits as you needed to get the correct values. But in this case, if you're using an environment variable and you don't realize it until about halfway through.
Yeah. So you see, so remember how before we had to change it to 37 and 38?
Yeah.
This time, leaving it at 135, but just adding our C's, we line ourselves back up again. So that means now, down here, I don't actually need to update those offsets. I only need to update the... So these 135 and 136 is actually correct now. I just need to change this to a 4 and add 2 C's. Oh, except also add that to the end of our local bin psmccli. There we go. So now what just happened was, let me put this in here where people might be able to read it better. So what we've done is convert our memory addresses into little endian. So following that, that's not what I want. Where's my Firefox window gone? Back here. Go to the first one. So following the format that we said that we needed to follow, that doesn't actually matter anymore. Let me just put it there. So we've got our little endian address, which is the address of our puts that we want to overwrite. We've got that memory address plus 2 in little endian after it. We've got our padding stuff that we calculated. And our random, this is just empty spaces, but our number of bytes that will mean HN writes our lower word. Then the number of bytes we calculated so that our HN writes our upper word. And then what that has done is basically overwritten this with our upper and lower words, which point to our environment variable. And then our environment variable has executed and given us a shell. And if I do a who am I, we can see that we're Pinky.
Yay!
Okay, hopefully that makes some sort of sense.
I think it's one of those ones where it involves lots of like conceptual.
It's very conceptual and hard to explain.
I will say I fully understand about 80% of that.
I might post this as a, like, I've got a write up which I will probably post on our blog, and maybe reading it and following it will make more sense. Like, it's easier to understand if you do it, I think. But so basically, yeah, all of these empty spaces you can see here, that's our
That's
that's our padding that we gave it.
yeah.
And
So
then
you can
eventually it's come to our jump address and it's
yeah.
jumped to our shellcode.
Nice.
Cool. From here, we do a similar thing to last time. So we go to the home and Pinky, and I have already done this because I didn't clean up after myself. But we add our public key into SSH so that we've got a bit of a checkpoint. And we've got a nicer shell. So now we can just SSH directly in as Pinky instead of PinkSec management, using our public key, our private key, and we're in.
Would you look at that? We're in.
Okay.
Oh, Jacob, you're a hacker.
Okay. Because that took 40 minutes to explain, I'm going to skip over the normal enumeration we would do. So our local enumeration. And basically, eventually, what's always on the to-do list locally is the sudo -l. And we see that we have sudo access to insmod and rmod.
Kernel modules.
Yep. And those are load a kernel module and remove a kernel module. I imagine he only added this so that every time you screw up this, you can remove it and try again, because I use that a lot developing this.
Because you don't want to normally give users the ability to enable and disable modules.
Yeah, exactly.
Yeah.
So we're just going to create a folder in here called those guys. CD into there. And now what we need to do is write our own kernel module that will execute some code and get us root access. And this is basically what a lot of Linux rootkits do. So apparently this sort of thing, we could just take an off-the-shelf rootkit and run it and it should work.
That's no fun.
But that's no fun, exactly. We've come this far and we've learnt this much, so I figured we might as well try writing our own. So what we do from here is look for how to write a kernel module, because they're not the same as just your normal C app. And what I went to was, excuse the brackets, this little tutorial on how to write a Hello World simplest kernel module. So they are just a C app, but instead of including is it like standard IO or whatever, you include this Linux module and kernel.h. And instead of a main function, you have an init module and a cleanup module. So we pretty much just want to take all of this. You don't need any of that defined stuff, I found out. Let's call it just hello.c, because we're going to write another one later. And of course the print didn't work. Why did that paste it like that?
Oh, did you do set paste again?
No. Also, it doesn't seem to copy or paste my first two characters.
Sounds like a you problem.
It is, but I don't understand why, because they're definitely highlighted. I thought last time it was maybe just I didn't highlight them.
Were you hitting I?
No.
Because if you weren't in insert mode, what happens is the hash
I just typed
will go nowhere, and then the I
yeah.
will activate. Yeah. That's why it worked in both situations. The I activates insert mode, and then the rest happily gets pasted. So you need to be in insert mode before you paste.
Before you paste. Okay, that makes sense.
Yeah, that's all it is. So it was a you problem.
It was a me problem. Okay, so that's our hello world. Then to compile one of these, I couldn't find a way to compile it directly using GCC. I mean, these are the arguments that you pass to GCC, but it works a lot easier if you just write a make file. So I copy pasted I couldn't get this make file to work. So I went to Stack Overflow, and Stack Overflow had this make file.
Thank the gods of Stack Overflow.
Yeah, exactly. So let's go set, paste.
And then you want to hit I.
Now paste. There we go. So the example on Stack Overflow actually used uname-r here, which if I just... It's because it was so that you could run the make file on any machine and it wouldn't make any difference. But I couldn't get it to work. Actually, I'll just do it exactly what was in there. So insert mode. This was, so dollar brackets to run a command. And then it was uname-r. And when you run make...
Well, if you do uname-r, what do you see?
Oh, that's right. So it doesn't think... Does it not think these are tabs anymore? That's why it's red. It pasted them as spaces. So you can see here that the in between modules and build, it doesn't actually execute that uname-r.
So what happens if you just type uname-r?
Well, that's what I did. So I just ran uname-r and pasted the value in.
Yeah. Obviously, in that context, yeah, it's not giving anything back.
Yeah. So I couldn't be bothered figuring out why that didn't work. So yeah, I ended up just running that locally and pasting it in as a hard-coded, because we're only going to use it on this box anyway. The M is return to the current working directory after the make is complete. So normally the make file will sort of go here, run the compile scripts, and then stay there. But the M just returns you back to where you were. And the hello.o is basically telling it which file to look for. Because you'll notice in here, we haven't told it to compile specifically hello.c. So it'll pretty much look for anything called hello and compile against that. That's what that's for. Now if you run make, we can see that it jumps into this directory, does a bunch of stuff, builds it, and jumps back. And we've got all of this crap. And the one that we care about is this .ko file, which is our kernel object, I want to say.
Yeah, I would say that might be it.
So now, and this, I don't know if this actually works, but we can run sudo insmod hello.co. And because it's already there, because I didn't remove it last time, now it will run. But we can see, so it loads it all up successfully. If there's any issues in this, the load doesn't work. I think the print, because we're running it in sudo, it doesn't print to our standard out. That's my theory, but I don't actually know. But it worked. It ran and didn't throw any errors. So pretty much from there, what I did was figure out how to make it run any kind of shell command instead of just, let me just open it up again, not our make file, vim hello.c, and we end up with, is there an easy way to delete everything in the file? I'm sure there is.
There is, but I end up spamming DD. I always
spam
forget
D a bunch of times.
I forget what it is. I think it might be D, and then you just move the arrow down a bunch, and then it D again, and it deletes everything in between, but I'm not really sure.
Yeah, okay, that makes sense. So pretty much from here, temp those guys. So we still have the same structure that we had before, but this time what we need is this env array and this argv array, and that sort of sets up our terminal and our arguments to the terminal.
These are the things that implicitly get given to anything running in the terminal, but kernel stuff probably won't get them.
Yes.
And so you need those to then, so that whatever command you try and get it to run, it'll have context. Yeah.
Yes. And then from here, the call user mode helper will actually run, this essentially run this terminal session in the current user context, which for us is the root user, because we're running it under sudo. So this is how I tested that what we were actually doing was working, because I just touched a file in temp rather than tried to make it print some info. Sorry, I just had a coughing fit.
Oh man.
Not
that's one of the
related.
symptoms of something. It's one of the symptoms of something that's going around at the moment, Jake.
No, I think it's just a combination of talking too much.
I don't know if you've heard of it. It's called being a Queenslander.
Probably. So let's just remake this. If we lsla into temp just to make sure it's not there. It's not. Good. Oh crap, it's not going to work because we've got a folder called the same name. So let's call it, if I go over here, that's a better name. I need to remake it. And then I can sudo, I already removed it. Ismod hello.co. Oops. Oh, it's insmod. My bad. And if we lsla in temp now, we have our touched by those guys, which is owned by root and created by root. So we've got not code execution, but we've got command execution as root on the box. Now, because this insmod isn't necessarily, like, it doesn't run a command or take standard in or standard out or anything like that. So we can't just directly tell our exploit to run, oops, I need to tell it to remove. Hello. So we can't tell it to just run bin sh and expect it to return a shell directly where we are right now. What we need to do is tell it to run an executable or binary that will give us a root shell.
Yep.
So from here, we go back to shellstorm, and I just pulled any bind shell because we can't run reverse shells because there's the firewall in the way still. So I pretty much just took any bind shell I could find. And in this case, I took this one, which is just a standard TCP bind shell on port 1337, because we're not using that either. So we pull that out, copy, paste it into comeback shell. I just created a directory just for this bind shell to help keep things clean. Vim bindshell.c, whoops, set paste, I paste, and we can see everything looks like it worked. Then we just compile it. The compile instructions in the script say to run it with all of this stuff. So I just did. We get a warning, but that's fine. It still worked. So now, just to test to make sure that it works, I just ran bind shell and we see that we've got a shell code with a length. And back over here, if we just go and see to 1337, we can see that we've got our bind shell working and connected, and we're connecting as Pinky. So now that we know that we can use this binary and that we can connect to it, we just need to make our rootkit run this binary as a root. Make sense?
It makes a lot of sense.
Sweet.
Easy done.
Easy done.
Too much banana. Definitely Benjamin Franklin. such a hard username to like get my head around. Like, because it's like far out. Like, this Benjamin Franklin does tell lies all the time.
So now we're going to build our actual rootkit. And I'm going to set paste again. And so the only difference this time, instead of touching a file, we are owning, except it's not bind. I think I called it bind shell, didn't I?
Yeah.
No,
so
I called it bind. So we're owning everything in this directory as root.
Yeah.
And then we're adding the sticky bits to that binary so that we can run it as Pinky and become root.
Yeah.
Pretty straightforward. We've done that sort of stuff probably before.
I speak only truth, asterisk.
Too much banana.
Just...
I don't know what that means. Oh, is that because I was coughing before? Too much banana? We also need our make file again, so I'm just going to copy our make file to here. Now it has to be called capital M. I don't know why, but when I tried doing it with a lowercase m,
so make
didn't
specifically
like it.
Make specifically looks for a file with that name.
It said it would search for make or make file, like make with a capital or with a lowercase. So I don't know why, but
I don't know. Maybe it's a config thing. I've done a bit of stuff with make. There was that one we did where I automated the entirety of that box own ages ago.
Yeah.
And I used the make file there to compile things so that you could dynamically give the target addresses.
That's it. I've been practicing too hard on the bananas.
This took a turn.
So we can see that we're not listening. No one's listening on port 1337 at the moment. So we go to, what did I just do? I've already made it. So we've got our rootkit. Now I just got a sudo insmod rootkit.co. And because I didn't get rid of it last time, now if we lsla on /temp/bind, we can see that our bind shell has the sticky bit set and is owned by root. So now all we have to do is temp bind
bind shell,
and over here connect up again, and who am I? I am root.
Oh, you did it.
We did it
in an hour as well.
So
or just over,
because
we started a few minutes early.
So we have our crappy sh shell, which I can use to just go straight to root. I didn't actually dump an sh public key on here, but we can do that as well. Looking at our home directory, we can see there's a root.txt. I don't think it matters if we cat the whole thing because this is like a public box anyway. Except tab doesn't work. So we can cat the root.txt and we got all of our flags and everything and we did it. Yay.
Yay! You just did some nice things there, man.
I did some breakage. And that's it.
Well,
we finally did it.
Nice work. We can finally get back to other stuff.
Yeah, this was an epic box and I learned heaps about the printf stuff. I learned about the writing kernel modules. The initial stuff wasn't actually too bad. The Drupal and all of that.
No, that was all pretty tame.
But yeah, hopefully you learned something too. It was fun. It was a good box. I enjoyed this. And maybe not next week, but sometime soon, the next one on the list is Pinky's Palace 4, which is another step harder again. So
we'll see how things go given the current global situation. Hopefully, we'll have no issues with being online. I wouldn't expect it, but the quality of the Australian internet is always something to worry about.
Yeah, that's true. And that's it. Thanks for coming along. Hopefully you learned something, Benjamin Franklin. Something that will be useful to your everyday job.
Anyway, have a good one, guys.
See ya.